Welcome to the video on dividing complex numbers. And before we can start to divide complex numbers, we're going to need another tool in our toolkit for dealing with complex numbers. And that tool is called the conjugate of a complex number. And a conjugate is really just a fancy name for a very simple idea. So let's say I had the complex number 2 plus 3i. Its conjugate would be, let me change my colors, 2 minus 3i. All I did here was I flipped the sign of the imaginary part, and only the imaginary part of the complex number. So to generalize, if I had any complex number, a plus bi, its conjugate would be a minus bi. So for another example, if I had the complex number 1 minus 4i, its conjugate would be 1 plus 4i. Again, very simple idea. And if you want to see what it looks like visually, let me draw it for you. Actually, let's draw an imaginary axis and my real axis. And if I had the complex number a plus bi, this would be my actual complex number. And now for the conjugate, it would still have a as the real part, but for the imaginary part, we would have a negative bi. And so you can think of this as a reflection in the real axis. So you can think of this as a pond, and the conjugate is the reflection in the water of the complex number. And now let's think about where this conjugate could be useful. So let me snap my fingers and make it all magically erase. And as you can see, a question also magically appeared from nowhere. So we're asked to divide the complex number 3 plus 5i with the complex number 4 minus 2i. And there's no obvious way to simplify this expression. I mean, we have an I in the denominator, and we're dividing two complex numbers, so we should ideally get another complex number that has some real part and some imaginary part in this form. So how do I get there? And to think about this, let me change the color. Okay. We need to multiply this complex number with another complex number, which is the complex conjugate of the denominator. And we see why in a second. So we'll multiply it with 4 plus 2i, and then we're also going to divide it by 4 plus 2i. And 4 plus 2i divided by 4 plus 2i is just a 1, and so we're not really changing the value of this expression. But what this allows us to do is that in the denominator, we are now going to have a real number, because this is in the form a plus b and a minus b. I have an a minus b here, and then an a plus b here. And so we've learned that when you have an a minus b times an a plus b, that's going to be a squared minus b squared. And that's going to help me convert this into a real number. Let's see how. So we have 3 plus 5i. I'm going to multiply it with a 4 plus 2i. And I'm going to just multiply each of these terms with the whole of the second term. So it's going to be 3 times a 4 plus 2i, and then plus a 5i times a 4 plus 2i. And in the denominator, I'm going to have something in the form a squared minus b squared. And so our a here is 4 squared minus our b here is a negative 2i. So I'm going to square that as well. And what's that going to be? Let's actually figure out the denominator first. We're going to have a 4 squared is a 16, and then the negative, and then a negative 2i squared. What's the square of a negative 2? That's going to be a 4 times what's the square of I? As we've learned, that's a negative 1, because by definition I is equal to the square root of negative 1. And as you can see, there's no longer an I in the denominator, and we have a real number, and that's going to be really helpful. So now on to the numerator. A 3 times a 4 is going to be, let me write that down, it's going to be 12, and then a 3 times a 2i is going to be 6i, then a 5i times a 4 will be 20i, then a 5i times 2i is going to be 10, and an I times I is going to be an I squared, which is just going to be a negative 1. So actually, instead of an I squared, I can write a negative 1 here. So this is going to be 12 plus 6i plus 20i minus 10. And now we can just, and all of that divided by 16. We have a minus sign here, and then another minus sign here. So 16 minus a negative 4 is going to be a 16 plus 4. And so now we're just going to add the real part to the real part. So a 12 minus a 10 is a 2, and then a 6 plus a 20 is going to be 26i, and in the denominator I'm going to have a 20. And just to write it in the standard form, that is a plus bi, I can divide both of these by a 20. And so it's going to be a 2 divided by a 20 plus a 26 divided by a 20, 20i. And so that's your final answer. And if you want, you can simplify this actually to a 1 over 10 plus a 13 over 10i. And now we have another complex number with some real part and some imaginary part.